How do you use AI to increase your customer retention rate while cutting marketing costs? The answer is crunch prediction. In this episode of the AI and Digital Transformation podcast, together with our guest, Virginie Marelli, Head of Research at dataroots, we will be discussing how to use crunch prediction to identify those customers who are more likely to leave your business, how to make them stay. Tune in to find out how to add AI and crunch prediction to your marketing strategy.
Hi, everyone, and welcome to the AI and Digital Transformation podcast brought to you by GMSC Consulting. For today, our guest is Virginie Marelli, and she is the AI tech lead for dataroots. And of course, I'll give the floor to Virginie to talk more about herself and also about dataroots and what they do in Belgium.
Hi, Angelique. Hi, Gabriel. Thanks for having me. So, just like in really, really short, I am Virginie. I first was a machine learning engineer at dataroots 5 years ago, where we were really a very small company. And we grew a lot because probably you've seen the field is attracting more and more talents and it's really booming. So dataroots also grew a lot. We are service company, so we also provide all kinds of services around AI and data. And so I became more a tech lead in AI, like coordinating projects and making sure the quality is good. And now, like since a year or something, I'm head of research and innovation within dataroots, so I take care of all the innovative projects, state-of-the-art kind of applications, but also training, because it's very important that we keep building these skills within dataroots. It's a key value for us. So when we learn something from those new projects, we always try to close the loop and train the other people as well. And we also do a lot of sharing session so that it's really a nice atmosphere where everyone can learn from their colleagues and from each other. I think that's a little bit of me and dataroots. I don't know if you have questions.
I looked at your bio a bit and I realized like you started out first as a data science, like you studied mathematics and then you ventured towards data science when you worked for ING, and then later on you moved towards AI. And like, how easy is it for people nowadays when they study math to venture towards like data science and AI?
Well, I think it's much harder now than when I was when I graduated, because at the time it was a lot less mature. The field was a lot more open, and you were doing a lot of POCs and analysis and small projects, while now it's a lot more integrated. You need a lot more software development skills as well. Then the mathematics is not enough anymore. And you see this also in the studies, in the university curriculum, because you have a lot more and more these master in AI, which pops up and are also there to show you that, well, yeah, now there is actual studies. And when I studied, this type of master didn't exist. So it's really funny, actually.
Yeah, that is really true. Nowadays, there's less and less math, which on one side, it's good. But on the other side, sometimes developers forget that to apply all of these libraries and API correctly, it is needed to understand what the underlying math is, what the requirements for some models to work properly are. And I think that's a bit lost nowadays. There's this idea, especially with the latest advancements, that in order to provide a successful solution, you just need to glue together a few APIs and you're done. And at first, it looks like you're done, but then like issues come along where stuff doesn't work as much as you would like, and the customer starts complaining. So I think it's still very important to have a solid grasp of the underneath theory, even if then 90% of the time you just use API or like libraries that have almost everything done for you. I don't know, what do you think of that?
No, I fully agree. I'm also a big fan of knowing what you are doing. And I also don't believe that these AutoML algorithm will replace me or the next data science team, because indeed, like you say, it's much more complex than also just the algorithm. You need to put all these pieces together, but in a way that it makes sense, in a way that it's an elegant solution, and it's much more to it than just a bunch of algorithm. I think there's also, if you look further than just the model, if you look at the ML ops part, these are all very important aspects that tend to be overlooked, but that are also very important. And in terms of mathematics, there is also a lot of implications. You don't want to have data leakage. You want to be as close to the reality as possible when you're developing. All these type of requirements makes it that it's very important that you understand what you do, actually.
Yeah, and I think today's use case is a good example where to discuss how these factors count in and how they make a difference. So I think we can delve into the details of the use case a bit. What do you think, Angie?
Yeah, we can. So for our topic for today is on churn detection, I think, or churn prediction. Okay, churn prediction. And if people don't know, churn is something that the marketing people in several companies would know. It's the most debated topic, I think, in their forums, because it's the question that people ask when they want to retain customers. So, for example, there are telephone companies that vie for your attention, and they try to get to get the attention and the loyalty of a customer as much as possible. And sometimes it doesn't work out. And that's where churn prediction comes in. You want to know when to anticipate when the loyalty is like failing already, and when to try to say, oh, just, let's reform the bond again between company and client. And that's where churn prediction happens.
Yeah. So today with Virginie, who is an expert in the field, we'll try to cover the maybe three main components of an ML solution for churn prediction, which is exactly how to implement a churn prediction model, how to use it, so how to leverage it actually effectively once it has been deployed in a way that actually helps the marketing people in a company, and finally, how to keep the model updated and how to make sure that it doesn't degrade in performance over time. So the stage is yours, Virginie, and we can, I think, start with how do you implement a churn prediction model? What are the main components and what do you need from your client?
Yeah, so I think indeed this is a good use case because it's not too complex. You can really easily understand what it means in terms of business. Like, usually retention is way less costly than acquiring new customers. So you really want to keep these customer inside your company. So it's quite easy to understand, but you have a lot of those problems that arise in many machine learning use cases, and it's not such an easy use case in the end, the churn use case. And the first thing is that you need to first translate this business goal, the fact that you want to retain your customer, you want to translate that into your data. And I usually call this like a technical goal. So what are you going to then achieve in terms of technical goals? And that comes down to the data that you have, basically. Do you have data about subscriptions? Are your customer paying some kind of subscription on your platform? or are they just like coming and visit the platform and without having a subscription? So there already you know that you need to define what you call the churn. Is it like when they just cancel the subscription, or is it when they stop using the platform? Because these are two different things. In this specific case, we chose to use the events. So every time that you would have an interaction with your customer, it would be called an event. Like he comes and click on the platform, he uses it to do some transactions. Every time that there is actually an interaction, or he calls the call center, it's kind of an event that happens. So you can monitor these events, and you can then see that at some point these events stops or fade away, and that's when you have your churn. So that's what we then define as the churn moment. But it's already too late, because like if the customer has churned, well then it's probably going to be very hard for you to get this customer back into using the platform.
Yeah, and to this point, I would say that many applications in also industrial settings, I'm speaking about predictive maintenance, rely on a very similar data collection and process, because in the end, you are trying to predict when your customer will fail somehow. But you also outline a very important point here, and that is that it is critical to the success of this application to identify with the customer what exactly churn is for them, which is not a straightforward answer, and also model and define your data acquisition. And this is where you can have all of the libraries ready, but you really need someone who can help you understand exactly how to translate your business requirements into technical requirements, and how to actually collect data that is coherent with the goal that the client has in mind. So those are also very important points that already give an idea of how complicated it might be and not so straightforward. And so at the end, once you have collected the data and you have understood with the customer what they actually want, what would be the next phase of the development of a churn prediction model?
Well, I really, really like the fact that you compare this use case to a customer feeling. But yes, so once you defined that and you know your data and everything, I think what is very important at this stage is also to make clear what is the success criteria. So a machine learning model is not deterministic. It's never going to be 100% certainty that you reach or you find all the churners. So you want to set with your business, with your stakeholders, what would be an acceptable success rate. Because if you can predict only, I don't know, 10% of your churner, maybe it's not worth investigating further, and you just don't want to continue the project. So that's also something super important, is that at every of these steps, like you mentioned, first step is data collection and understanding, is you kind of stop it for a moment and you look and you say, okay, do I continue or not? Does it make sense to continue? And so you set this criteria to be able to do that in a later stage.
Yeah, it sounds straightforward, when by practice I think it's not, because people think, oh, just because we make a machine, it's going to be accurate. And what's funny though, like both of you, while you were discussing about the churn prediction model, like the first thing that come to mind was, how much data actually does a business need to collect to create the model? Because I know for a fact, like some businesses like to say, oh, we don't like people to churn, so that means zero space for failure. But sometimes you need to fail.
Yes, which is also, I think, another way of asking how big a business must be to exploit successfully the deployment of a churn prediction model. Because in in order for the model to be statistically effective, you need to have enough data, and this in turns depends on the size of the business, assuming they're collecting data, which is not a given.
It's super hard actually, because it's not only the size of the data that is important, but also how many churners you have, because it's kind of like a contradiction, but you would like them to have a lot of churners, because then you can detect the pattern and then you can predict the next ones. But actually they would like not to have these many churners, because then it's hard for the business, it's bad for the business, right? So this type of problem is usually unbalanced heavily. You have a good customer base, and then you have a couple percent churners, like between 0 and 10% is usually what you see. And this makes it very hard to determine how many data points you need, but also because you need enough recency, because these type of problems are temporal. You can have someone that was not churning for a year, and then at some point, suddenly there is maybe another feature on another platform for another product, and this customer is going to churn. And so at the beginning, your model would consider that this data point was never churning, and then at some point there is a change in behavior in churning. So recency is very important, and the number of churners. But there are techniques that you can use to counteract this and counteract the unbalancedness of your data.
So ironically, the worse you are at your business, the best is for churn prediction.
Yes, definitely.
But this is good for people who are bad at business.
Yeah, I mean, it also depends on how much money they have left. If they're bad at business.
That is true. And what you just said, so that it also depends on external factors. Maybe a new product that was just released in the market that is in competition with the customer's product. So this raises the question, how do you monitor the performance of your model in production, and how do you detect what kind of steps must be taken in order to be sure to detect when the model begins to underperform? Because it's not just, of course, the accuracy, because it might be that because of an external factor, it's underperforming, but the model is still good. I mean, the business might be underperforming, so you have a higher churn, but the churn model might be performing well, or the other way around. So how do you, what do you need to deploy aside from the model in order to detect whether there is a change in the data or in the change in the market that requires somehow to take action, either on the model or on the business?
It's actually a very good question. And in this case, it's very specifically hard, because you don't predict churn for churn. Yeah, right. If you predict churn, it's to stop it, right? So at some point, you don't want that your model predicts that much churn anymore, right? Because usually when you monitor a model, you would monitor its prediction. And if it's always kind of predicting the similar amount of churners, then you would say, oh, okay, my predictions look like similar to what I developed in my training data set in my development moment. But in this case, what you would hope to see if you implement the right marketing strategy is that your churner decrease, and also that the model decreases. So you cannot really monitor that part of the prediction, because then it's always going to say, oh, well, you have less churners than when you initially trained the model. So you cannot really look at that part. So what I would implement in this case is data drift. So you look more at the input data. And there you have a lot of different ways you can implement it. You can implement it feature per feature. So you look whether each of the features that you have implemented is following the same distribution as the one in your training data set. Or you could look at the whole set of feature all together, so multivariate drift detection. And there you use techniques to reduce this data and to also check whether the reduced data look similar to the one of your training set. But it's always comparing what you have now with what you had in your training data set.
Mm. And do you think there's this possibility that you have too much data, like not data points, but too much how do I call it? Data.
Too much information.
Too much information. Not the number of data per column, for let's say, but the number of columns. So the number of information that you're gathering is too much.
Attributes.
Yeah, attributes. So the number of attributes, do you think could be too much in this case for a churn prediction model?
Well, it could be it's actually related to the number of data, because the more data, the more attributes you can have, because then your space is more balanced. But so yes, if you have not a lot of data points, then you might want to look at your attributes and reduce them in order to not have too much overfitting on those. So you try to capture the essential information, and you usually just reduce dimension, for example, or you cut some of the features based on their importance. There are a lot of different techniques, and it's indeed something that can stabilize the model. So if you take good care of this, afterwards your model will be much more resilient to changes, small changes in the data. So it's very important step indeed.
And this is another arrow, let's say, in the quiver of you cannot just get all of your data and feed them into an auto ML model, because it might be working well on your test set, but then you need to understand how reliable that solution is, and also in a way how explainable that performance is. So I really like that you mentioned data drift before, which is a change in the data distribution, which is like saying something changed either in the customer or in the market. That's what it means. And this introduces ML operations, which is something that is not well understood by most of customers, because once you deploy a product, an ML product, the job is not done. Unless you decide to keep it at the research stage, then you need ML operations. So how would you explain why a customer needs ML operations and maybe the main components of it?
Wait. What's ML operations?
Yeah, exactly. So what is ML operations for someone who doesn't know machine learning, and exactly like how is it deployed, and what do they need in order to have it work efficiently and correctly?
Yeah, so I think it's originated from DevOps. So it's like how to put software in production in an efficient way. So you have the whole automation around code development, so that when you develop something, it will be quickly deployed in production. So you have all these CI/CD pipelines and the automation of that part. And you need that as well in the ML project, because you also have code. But on top of that, the specificity is that you have this model, and the model is something fixed. Like a bit of a misconception, I think, is like people think that a model is kind of magical. It will auto-train and it will auto-learn and it will do all these magic things. But actually, I'm sorry, it doesn't. And you need to put some work into it. And why is it important that it will keep learning is because, well, these are changes, especially for this type of use cases that we are discussing. Well, the platform may change, new features come, other users as well come, and the behavior change. But also think about just like the crisis in 2008 or the Ukraine war. All these type of things affect your model. And so the model needs to keep learning those patterns to be up to date, to provide accurate predictions. And that means that you actually have to put into code and deploy this the whole development, but in a kind of an automated way, so that it would go over all these steps again. So defining the targets, so creating the features, doing all the feature selection, everything we just discussed, evaluating the metric. All these type of steps needs to be automated into pipeline and rerun automatically every month or every time that we were discussing data drift. It's a bit maybe advanced, but you could even think, oh, when there is a change in my data, I want to re-trigger the learning part.
How long do you think does it take for like the team to reassess again? Like, for example, there are two cases, like to check whether it's still a good model and to check whether a new input or a new I don't know, accessory in the mod. I have no idea the terminology. Like a new thing was integrated to the model, and then you want to see if it works better.
What do you mean? Explain better.
New feature.
New feature, yes, a new feature. Yeah, how long does it take, like for these two cases, for the meeting between? I assume that it's not only you guys, like the people in AI, who actually convene, but also the people in the business area of the company, like the marketing people, the sales people, and then maybe some data scientists also convene with you guys to reassess everything, because it's like somehow like a war strategy.
Yeah, I think this is a very business oriented question, and I think it's useful because for people who do machine learning, this might be obvious, but it's really not for someone who doesn't do it. So it's like, if something changes, how long does my AI consultant require in order to update the model and everything? And I think the question is more, what do you need in order for this process to be fast? Because that's the real question, I think. What's your opinion on this, Virginie?
Well, indeed, but I think like you mentioned two important points. There is one, the automatic retraining, and that should go fast with all the tools that are now on the market. You should be able to automate actually everything from the model retraining, and then you can store it, what we usually call a model registry, and then you evaluate whether the new model is better than the one which is deployed, and then if the new one is better, then you can automatically redeploy it. So this part can be really automated, but then it's more like making sure that the performances keep up to date with the one that you developed. And like that, I have a model that is running for 2 years now, and no one has touched because it's automatically retrained, and it's really actually cool to see. And the second part is more the continuous improvement journey that you want to do. I think a lot of the projects we try to do a proof of value, right? You want to see if AI can work for you, and so you develop something maybe small that you try to deploy quickly, and then see directly the value. So think about a small pilot or a small marketing campaign, and then you want to continue on this journey and improve and do the rest of the project.
Well, I think that yes, that's how it should be, but I know personally, and even though it shouldn't be like this, that many AI solutions that are deployed and used in production, they do not have a good pipeline of machine learning operations attached to them. Sometimes it's just a bit more than a Jupyter notebook, so like an experimental code just wrapped and deployed in the cloud. And there is a significant amount of percentage of this kind of solutions out there. And I think it's important in this podcast, where we also speak to business people, to understand that if the solution that they have is of this kind, so there's no machine learning operations pipeline, then it's not how it should be. And they should demand from their AI consultants to also add that, because it's really important in 2023 to have that.
So you think that there are many companies that don't have the ML pipeline and like they rely heavily only on data?
Yes, I think so. Because sometimes, more often than not, actually, I think providers of AI solutions are not companies that are specialized in AI. They're companies that do a bit of everything, and maybe they discuss with their old customers, and they got asked, "Could you do these machine learning models for me?" And sometimes they ask someone who doesn't have any experience, and they go online. Now they will use ChatGPT probably, and they will stick together a solution and deploy that. And it does not conform with the standards that a good machine learning solution should have. But this is very common, like code that is deployed oftentimes is not even tested properly. And this is very common, sadly. And this is not how it should be. So I think for all people who are from the business side that are listening to this podcast, I would like to tell them, like, make sure that you have ML ops pipeline as well as tested code, because that makes a big difference in how reliable your solution is. And you cannot really afford, I think, in 2023 to have a model that it's just there and maybe it used to perform well, but now it's performed badly and you're not even aware that it's performing badly.
It sounds like a badly managed ship.
So yeah, I don't know your experience, Virginie, but in my experience, it's more common than I would like to see.
Yeah, I agree with everything you say. It's like it's indeed something super important, and you should demand. Basically, dataroots was created with this from this frustration. We also saw a lot of those notebooks and the models just deployed like that. And since the beginning, since the creation, we've been focusing on making it right, because that's also why a lot of models are not even deployed sometimes, because you don't think about it at the beginning.
Mm-mm. Do you think like since you have a very diverse background compared to the many machine learning engineers we've encountered, like do you think having a very analytical mindset, because that's something you had, I think, to create this analytical mindset and also had the experience in data science to understand how to approach this problem on churn prediction? Because I think if you ask some other machine learning engineer, a freelancer, let's say, who doesn't have a strong foundation, would try to do what Gabriela just said.
I don't know if it has to do with analytical background or maybe more with experience, and because you've seen them fail, how the project failed, and you know that it will eventually, if you take some shortcut, or if you just deploy a notebook, or if you do this type of mistakes, then it will at some point fail, or will not deliver anymore the prediction that you want. So I think it's more from that experience.
Yeah. I'm happy we know, but many people out there, they don't know.
Yeah, many people think that, like, as what we are seeing now, people who are ignorant of AI would say that AI is, or machine learning is, a silver bullet. And we continuously disprove this in our podcast, I think, that there is always the need for human intervention to make AI be an ally rather than be an enemy, and let them do our job, when in fact it's I think still far from that at the moment, despite having like ChatGPT circulating all over the world.
I think another question that we wanted to ask you was, how does this churn prediction model integrate with the classic A/B testing that marketing people perform when they try to improve the marketing of the company they're working for?
Yeah, actually, it's a very interesting questions. I think something that we did not do right, or maybe lessons learned from this project, is that marketing should have been involved much earlier. at really the beginning, I think, to already think about the strategy to test it, because it took us then quite a long time to implement that strategy, that testing strategy afterwards. So I think that's something that we should have done better, maybe. But we did come up with an A/B testing strategy that we implemented and created some marketing campaign. So it was really good to see that. Difficult also because marketing just wants to stop the churners, and what you want as a data scientist is to know whether your model was correct, right? And so you want these two groups, and you want to be able to see whether your marketing campaign had an effect on the treatment group and no effect on the control group. But for that, you need to let some people churn, and it's always some kind of difficult negotiation with marketing.
Well, I have a question for you both. Do you think it's difficult to find a common language between non-experts like marketing people who are not very patient and data scientists and machine learners who require more patience in solving these kinds of problems?
Well, I think it depends on the marketing people. Like marketing people should be very data oriented in theory, because there's a lot of testing in marketing. The A/B testing is really like the foundation of modern marketing. But sometimes the business people come in and they expect immediate results, while this approach is more like a mid-long-term result where you try to continuously improve. I mean, this is what I think. What do you think of this, Virginie?
Yeah, I agree. And on top of that, I would say that sometimes it's not always easy to sell your solution if you don't have explainability. Because a lot of these models are black boxes, and they are focused on performance, so accuracy rather than explanation. And then when you come up and you want to say, but yeah, look, my churn model, it's great at predicting churner. And then you're going to say, yeah, but I cannot do anything with that. You have to also tell me what should I say in my marketing message. And there comes a bit like, yeah, well, I don't know, it's your job. And then and then comes maybe a bit of misalignment. And I think that's why including them since the beginning of the project might be better, because then they see what type of feature you put in the model, and then you can also steer that a little bit and help you. And then in the end, they have a much better understanding also of the process and how you've developed the model. They trust it a lot more.
Yeah, and this is a very important point. I think I love that you mentioned explainability, because it's an I think, estimated component of machine learning solutions. And I think it's explainability has two major components. Like one is the ability to explain the model itself, so how it works, what are the features that are used and how they're used by the model. And this is what you were just saying right now, Virginie. And the other one is being able to explain the performance of the model, saying like, for example, in this context, the model performs with this accuracy, while in another context, it performs with another accuracy. And when you add these two components together, you can really give the model as a tool that has a predictable, somehow, at least statistically, performance, and that can be really used effectively. But in order to do so, and we go back to the original point, you cannot just fit everything into a black box or some ML auto ML pipeline, right? Because usually those tools choose the most performative model that sometimes is very far to be explainable. Like I think it happened often to you that you had to maybe sacrifice a few percentage points of accuracy for a much more explainable model. Is that true?
Yeah, certainly. And I think currently the tools for explainability are still very mathematically driven. They are insightful for the developer to understand better how the model has taken decision, but they are still very often hard to understand for the end user, because they are you have so many features, and the human brain doesn't work so mathematically usually. So you need anyway to have discussions, to test, to also pick up some specific use cases, to go in depth into this before you go and have the whole buy-in of everyone. You can use like those techniques like Lime, Sharp, or feature importance, but on top of that, you need to have those discussions as well with the business stakeholders. It's very important.
Yeah, and that made me realize like the importance also of data visualization, because some marketing people I know also love that they could try to convince the bosses to act on something when they're able to deliver a message that's understandable for the thought leaders, for example, in the company. And usually making it more visual, I think, helps.
Yeah, which is another point where machine learning helps a lot, because if the number of feature you're using is maybe 20 or 30, you cannot easily show this data on paper, and you can use machine learning to turn this 20th dimensional representation into something that fits on a paper actually. So that's another thing why you should really collaborate with people who know how to do this. And I think that there's one more important advantage of having an explainable model, and I think it also helps the marketing people to understand what kind of actions to take in order to reduce churn, right?
Yes. And it's not so easy to give them that actually, because it will really depend on the data that you have collected. For example, in the case of the events that you like collect, like every interaction, it's extremely difficult to give them an explanation, because basically the explanation will be, well, there was a change in pattern of usage in behavior, but you don't know what caused the change. And then you need to start gathering other type of data. For example, was there a new feature released, or was there some changes in the platform, and that had an impact on the change? And then you need to start correlating and analyzing the trying to find an explanation to your behavior changes. You can also look at customer complaints, for example. Did he call a lot your call center? And this type of data is super interesting. It's not always easy to gather either. You have privacy concerns as well if you use call centers. So not so easy, the root cause analysis.
Yeah, it's interesting that you brought up privacy, because it's something I care uh, very much. And with the recent legislators, not only in Europe but also I think around the world, they're now witnessing the importance of privacy, and so many countries have been drafting some regulations which could affect these kinds of applications on AI, like churn prediction. How do you how do you manage with the privacy right now, and do you think it will change drastically in the future?
Oh, yeah, I think, well, I hope we already implement a lot of the regulations, because we care also. And so, for example, we never used with the private data like addresses and so on and so forth. It's usually anyway not so impactful. You can aggregate it. It doesn't really make a huge difference. So like in terms of data, you should always anonymize it anyway. And I think also a lot of the other part of the regulation related to traceability and making sure that you can reproduce or explain the result, it's also already part of the ML ops strategy, because there you can always know and trace back which model was used and how it was developed, and what type of explanations are linked to it. So I think it's very nice if you already start integrating MLOps now, because it's a big part of the legislation that is coming up.
Yeah. So it's something you discussed with me earlier, Gabriela, the importance of having an AI expert to actually value this, let's say, privacy, because not many, I think, would care, or now they should care. But
Yeah, I think it's more cautious and wise to already have this kind of approach, because in the future, given the AI Act that has been drafting right now and where we are going as a European Union, but not just Europe, I think the question of, is the data that you're using compliant with privacy, with anti-discriminatory policies, for example, is going to be important. And you might, because if you don't do that, you might end up investing a lot of money on a model that works well, but it's using data that cannot be used. And so in the end, you will end up either with a big fine or not being able to use it. So I think here on this subject is very wise to play ahead and trying to deploy models that are already compliant with this new regulation that I think will be ubiquitous very soon.
Yeah.
I think.
But do you think people actually find out if you violated this?
That is a very good question. I don't have an answer. What do you think, Virginie? Do you think people would find out or no? And or maybe companies would just ignore and say it anyway. Nobody can see.
Well, I think for so this is a risk-based scale under the AI Act. So you will have like very high risk applications, and this one will be audited. So I think people will find out. But for the lower risk level, then you have a lot less also compliance. It's still my advice that you should be ethical anyway in the model that you create. So, but yeah, for the high risk, I hope there will be.
I hope so too.
So I think this is a good point on which to end the technical part of this podcast. So it's for the business people, this reminder of be sure to ask the AI provider you chose how they work, what their policies are, what their best practices are, because that makes a difference both in the price of the solutions, but also a big difference in the quality and in the risk level that you are accepting by integrating these applications in your system. So that makes a big difference. So make sure to ask. And my suggestion also is, if you don't have any AI expert in your company, bring along a software engineer who's fond of software good practices, because maybe doesn't know the good practices of machine learning, but can understand whether a company who does machine learning uses good practice at all. That's something important. I am amazed about how often business people, managers, CTOs, or don't have a technical background, sign deals with software company providers without bringing along their own senior developers to vet the supplier. It's like going to a trial without your lawyer. I will never understand why people do that, but it's very common. So it's like you would never go to a trial without your lawyer, right? So never buy software from another company without bringing your software developers, if you have any, because that make a big difference.
But I think it's the same mindset, like creating a model without the marketing people on board in the beginning. It's like your wingman's disappeared, and you need a wingman.
It's not just about the wingman. It's really that there's this thought that there is some truth to it, that software developers are always somehow naysayers. They always find problems. And so they don't bring them along, because it's like they don't understand the technicality of business. And there is a good share of truth in that, but just you should listen to them anyway. Then you can discard 80% of what they say, but listen to them. That's what I'm saying. But because it's dangerous not to. And in my experience, this happens very often. I don't know. How is it in your experience, Virginie?
Well, I don't know. I have, indeed, maybe the feeling that the expectations are not always realistic, at least, about what AI and machine learning can do, and that business people are expecting the moon, or they see all these ChatGPT models, and then they expect some really quick result, or they expect that the model will retrain itself. It's actually a lot of work and a lot of human intervention, like you mentioned.
True. So my advice for business people, if they're in LinkedIn, to follow people who are very technical as well, because they have this tendency to be in the bubble as all of us are, and just being in an echo chamber of, oh yes, AI is cool, but they don't know what AI is.
I remember 5 years ago, like, this is a small, sorry, this is a short story. And I remember I was at the GTC conference in Munich, and a businessman approached me and asked me, so do you think we can make an AI system that can just read the evidence and predict with high accuracy the outcome of the trial? And to this person, it was entirely feasible and actually a very legitimate question to ask. And I was like, no, that's not the case. That's really not the case, especially 5 years ago, but still, right now, it's still very hard to do that. But the reaction was not, oh, okay, I think of something else. No, I just went to another person asking the same thing, because it was basically going on asking people until he found someone who said, okay, maybe I can do that. This is another thing that happens often. It's like, I don't like your answer, so I will just look for someone else answer that I like. And in the end, they always find someone who will take their money, even though it's not really reasonable. Well, but anyway, I love this conversation. We, I think, really highlighted a lot of very important points, and there are a lot of insights. So thank you so much, Virginie, for being with us today. And as usual, we'd like to end our episode with one last question, which
Yeah. So to close our episode, we'd like to ask you if you have a recommended book that our listeners could read. It could be technical or non-technical. And yeah, a book that you like.
Yeah. So I think we discussed a lot of the today about the ethical and biases that you can put in your models. And one of the book that I read, it's already a couple years ago, but it's Weapons of Mass Destruction. It's like from Cathy O'Neill. And it's really cool because she has all these examples where models were used in some kind of shady areas. Actually, there is one model in the US that was used to predict the recidivists, so people that would do again some crimes or some bad mistakes. And this is one of the examples. It's funny that you mentioned it or something similar just before. I really encourage people to read this because it's an eye-opener into how you should be ethical and care about what you put into your model.
Weapons of Mass Destruction.
Yeah, I think one of our previous guests also recommended this. So it should be
I didn't read it yet. Yeah.
It's highly recommended.
I should buy it then. Okay, thank you again, Virginie. This was a wonderful conversation. And we hope the listeners also enjoyed this episode.
Yeah.
And see you next time.
Yeah. So people, if you like Virginie Marelli and also want to work with dataroots, we will be providing her contact details in the show notes, so you can reach out to her directly. That's it. And bye, everyone.
Yeah.